Hi all, welcome to another session of Boilchem Tutor. In this session, I am discussing the preparations of amine by different methods. Let us start the preparations of amines from haloalkanes. When ethanolic solutions of ammonia is heated with alkyl halide in a sealed tube under high pressure, we can get amine. One important point to note is that if the ammonia concentration is high, then the reaction will stop at primary amine. But if the alkyl halide or haloalkane concentration is high, the reaction will not stop at primary amine. It will continue up to quaternary ammonium salt. Let us see the mechanism of the reaction by taking an example of methyl iodide. Methyl iodide is having the formula CH3I. And CH3 occur is like positive charge and iodide occur is like negative charge. So if an ammonia is attacking, then ammonia is having a lone pair of electron. It will donate a pair of electron to the carbon and form a 5-membered transition state. So in the next step, the easily iodide will be relieved and ammonia can be attached. Then if another ammonia is added, then this ammonia can extract its positive ion from that ammonium compound and form the amine and the ammonium ion as the byproduct. And this ammonium ion will add to the iodide ion left from the first step and form the ammonium iodide. So from mechanism of the reaction, we understood that first ammonia is acting as a nucleophile because first the ammonia will donate a pair of electron to the carbon. Second ammonia, when we are looking, it is abstracting a proton from the ammonium compound. That means it is acting as a base. So in this reaction, the formed amine is again having a lone pair of electron on the nitrogen atom. Again, if the alkyl halide is more, then it will again that this nitrogen from the primary amine can donate a pair of electron to the alkyl halide and it will continue the reaction up to secondary, tertiary, quaternary ammonium salt. So when we look the laboratory scale preparations of this reaction, we can use alkyl iodide as the alkyl halide because alkyl iodide are easy to handle and iodide is a better leaving group. But when we are using in a large scale, that is industrial preparation, we are using alkyl bromide. Therefore, the order of the reactivity of alkyl halide is that first alkyl iodide will easily react and then comes the alkyl bromide and then comes the alkyl chloride. This reaction is otherwise termed as Modolysis reaction because here when we are looking this reaction, ammonia is splitting by alkyl halide. That is why it is termed as ammonolysis. Another important point to note is that this method is not useful for the preparations of aryl amine because aryl halide are less reactive towards the nucleophilic substitution reactions. Another important method for the preparation of the amine is by reduction reaction. There are various functional groups which can be reduced to amine. Let us see which all functional group can be reduced to amines. So first will be the reduction of a nitro compound. That is, the nitro compound is having a functional group NO2 and it can be reduced to amine by taking various reducing agents such as hydrogen in the presence of nickel, palladium, platinum or lithium aluminum hydride or sodium borohydride, etc. This method is useful for the preparations of an aryl amine as well as the alkyl amine. So any nitro compound can be reduced to amine by taking any reducing agent such as hydrogen in the presence of nickel, palladium, platinum or lithium aluminum hydride or even stannous chloride SnCl2 can be used for the reduction. So another important functional group which can be reduced to amine is cyanide. Cyanide is having the functional group Cn and C is bonded to hydrogen by a triple bond. And so, the cyanide, when it is reduced with hydrogen in the presence of nickel, palladium, platinum or lithium aluminum hydride or sodium in the presence of ethanol, these hydrogen will be added to this triple bond of Cl and primary amine is up. But if we are taking isocyanate, that is NC, it is reduced to secondary amine by reductions. So alkyl cyanide undergoes undergoing reduction, it gives primary amine, and isocyanide undergo reduction to give a secondary amine. Another important point to note is that when an alkyl cyanide or an aryl cyanide is reduced with sodium in the presence of ethanol, we are getting a primary amine, and that reaction is having a name called Methylamine Reduction. Another important functionality which can be reduced to amine is the amide. Amide is having the functional group CONH2. So if it is reduced with any reducing agent such as hydrogen in the presence of nickel, palladium, platinum, or lithium aluminum hydride, or sodium in the presence of ethanol, we are mainly getting primary amine as the main product. But if we are taking a substituted amine, then we can get secondary, tertiary depending upon our substituted amide. So another functionality which can be reduced to amine is the oxide. This oxide, how it is obtained? Oxide can be obtained by the condensation reaction between an aldehyde or a ketone with hydroxylamine, that is NH2OH. Then corresponding oxide, after getting an oxide, it can be reduced to amine by treating with any reducing agent, hydrogen in the presence of nickel, palladium, platinum, or lithium aluminum hydride, or sodium in the presence of ethanol, etc. etc. Another important functionality which can be reduced to amine is the acide. Acide is having the functionality N3, and acide can be obtained from an alkyl halide by treating with sodium acide, that is NaN3. After getting the corresponding acide, we can reduce to primary amine mainly by taking any reducing agent such as hydrogen in the presence of palladium, platinum, or nickel, or lithium aluminum hydride, or sodium in the presence of ethanol, etc. The last method is the reductive amination of aldehyde and ketone. So when an aldehyde is treated with ammonia, it results in the elimination of a water molecule and form alderine as the product. After getting an alderine, when it is reduced with any reducing agent, it results in the formations of a primary amine. Similarly, if a ketone is taken and it is reacting with ammonia, it results in the elimination of a water molecule and result in the formation of ketamine. And if this ketamine is reduced, again we can get the primary amine. So we found that nitro group can be reduced to amine by taking any reducing agent. And again, if you are taking the cyanide, it will be mainly reduced to primary amine. And if you are taking isocyanide, it will be mainly reduced to secondary amine. And if you are taking oxide also, it can be reduced to amine. And acide, it will be mainly reduced to primary amine with the elimination of the nitrogen molecule. And last step is the reductive amination of aldehyde and ketone, and it results in the formation of an amine by reduction. That is all in this video, and in the next video we will be discussing about the Hofmann-bromamide degradation reactions and Gabriel-Thallamide synthesis. Stay tuned for the next video. Till then, bye.